Let's see how we can find horizontal asymptotes for rational functions. Horizontal asymptotes. Now, horizontal asymptotes are quite dependent upon the degree of the numerator and degree of denominator. So number one, since these two numbers n and m are two positive integers, so they can be equal. One is n is greater than m or n is less than m. So those three things can happen. So the first condition is if m is greater than n. That means if the degree of the denominator is greater than the degree of numerator, then in this case y equals to 0 or x-axis is the horizontal asymptote. Now let's take second. If m equals to n, if m equals to n, then y equals to leading coefficient of n of x, so which is an divided by the leading coefficient of d of x, which is bm. Since these were the leading coefficient that we have previously assumed, okay, so that is the horizontal asymptote. Number three, if m is less than n, denominator, its degree is less than that of numerator, then the asymptote that we'll be getting will be a slant line, okay, q of x, where this q of x is the quotient whenever we divide n of x by d of x, where y equals to f of x equals n of x divided by d of x equals to q of x plus r by d of x. So this is the quotient of the division. So this is our slant asymptote, or we can say oblique asymptote also. Let's take an example. So this is a function, rational function. Then you can clearly see that degree of 3x square minus plus 2x minus 8 equals 2, and degree of x square minus 4 equals 2. So they are same. Since the degree of denominator and numerator, they are same, so the horizontal asymptote in this case would be y equals to the leading term an divided by bm, which is the leading coefficient of this function is 3. Leading coefficient of this function x square minus 4 is simply 1, so that's 3. So the horizontal asymptote is y equals to 3. So we just divide the leading coefficient of numerator by leading coefficient of denominator. Take another example. Y equals 1 over x square minus 9. Then here you can see that degree of the numerator is 0. Okay, this is a constant function, so its degree is 0, and degree of the denominator x square minus 9 is 2. Then you can clearly see that degree of denominator is greater than degree of numerator. So in this case, the horizontal asymptote is simply y equals to 0, which is x-axis. Let's take another example where you can clearly see the degree of the numerator x square minus 2x minus 8 is 2, and degree of the denominator is x plus 1 is just simply 1. So degree of the denominator is lesser than the degree of numerator. So in this case, we need to do simple division. Okay. So let us set this x plus 1 equals to 0. That is x equals to negative 1. Then we can write this as negative 1 in here. So 1 is the leading coefficient, negative 2 is the next coefficient, and negative 8 is the next coefficient. Then this comes down. Negative 1 times 1 is negative 1. So that is negative 2 plus negative 1 is negative 3. And then negative 1 times negative 3 is positive 3. Negative 8 plus 3 is negative 5. So this is the remainder and this is quotient. So I can write remainder is negative 5 and quotient is simply a function 1x minus 3. So x minus 3 is the quotient. So this is the case where we get slant asymptote, where slant asymptote is simply y equals to the quotient, okay, x minus 3. Okay, so x minus 3 is not that hard to draw. Negative 3 lies here, suppose, and 1 comma 1 would be somewhere here. So this would be the, so this line would be the slant asymptote to the given function.